Today's lesson is about the reason for the seasons. So last week we talked about rotation and revolution. So remember, rotation is the movement of the Earth as it spins on its axis, so staying in one place. It takes approximately 24 hours, and because of this, we have day and night. Now remember, we said that it rotates in a counterclockwise direction. Revolution is the orbit around the sun. One complete revolution around the sun takes approximately 365 and 1/4 days. This is why we have a year. Now remember, we have the leap year every 4th year to make up for that day. So remember that the Earth is rotating on that imaginary axis, which is the line going through the center of the Earth. If we look at that, we're going to see that it's actually on an angle. It is tilted. So the axis is tilted approximately 23.5 degrees. Now this tilt is really, really important. Because of it, there are areas of the Earth that get more heat at times and more light from the sun at times. And then there are areas that other sections of the Earth might get less energy from the sun. So let's take a look at exactly what happens because of this tilt. So you see we have our imaginary axis running through the Earth. So the tilt is at about 23.5 degrees. Now we have our sun's radiation over here. So the sun is always going to strike the center of the Earth, that equator area, the most. So you're going to get your most direct radiation right here at the equator. So if we look at that equator again, you see how it divides the Earth into two parts. You have the northern hemisphere and the southern hemisphere. Now this is going to make a difference when we talk about seasons. We live in the northern hemisphere, so that's where we're going to be focused mostly. It's important to note that when we talk about the southern hemisphere, we're talking about opposite seasons. So remember, we talked about the distance between the sun and the Earth. Well, we gave it an actual assigned value. So the distance between the sun and the Earth is called an astronomical unit, and it's about 150 million kilometers. Now remember, we talked about revolution. We talked about that the Earth did not complete its revolution in an exact circle. It was more of an elliptical orbit. So if we look here, you see these arrows showing the direction of the Earth's orbit around the sun. It does move in a counterclockwise direction. Now, because of this elliptical orbit, there are times when the Earth is closest to the sun and times when it's farthest away from the sun. Now remember, it is not a significant difference in distance. We are actually closest to the sun in January, and we are farthest from the sun in July. So you could see those will be expecting different temperatures. So distance is not related to our seasons. So why do we have seasons? Well, in summer, the north end of the axis is tilted towards the sun. Because of this, we end up with more daylight hours. Think about it. When it's summertime, you can stay outside a really long time because it doesn't get dark until like 8 o'clock. The north end is also getting more direct sunlight because it is tilted towards the sun, which results in warmer temperatures. Now, if we in the northern hemisphere are in summer, the southern hemisphere is in winter. So if we take a look at this diagram, you see the north end of the axis is tilted towards the sunlight. The south end of the axis is tilted away. So the north end, North America, where we live, is getting more direct radiation at this time. So we have higher temperatures and longer daylight hours. When it's winter, it's going to be the opposite. The north end of the axis is going to be tilted away from the sun, which results in fewer daylight hours and less direct sunlight. So we have cooler temperatures. Think about it. It gets dark early in winter, sometimes 5, 6 o'clock, so that we have less daylight hours. In this position, the north end is tilted away from the sun. Now the southern end is tilted towards the sun. So north would be in winter, southern hemisphere would be in summer. Spring and fall are a little bit different. During this time, neither end of the axis is tilted toward the sun. Because of that, we have fairly equal day and nighttime hours, and we tend to have those more moderate temperatures. You tend to not get the extreme highs and the extreme lows. Those are actually the best days. So in this position, you can see how half is illuminated, half is not, so that's why we say it's about equal. Neither end of the axis is tilted towards or away. So in this case, if North America is in spring, the southern hemisphere is in fall. Opposite, if the northern hemisphere is in fall, the southern hemisphere is in spring. So there are two factors that have to do with why we have seasons on Earth. The first one is that tilt. If the Earth was not tilted, we would have exactly the same temperatures and daylight hours every day of the year. The other factor is the revolution. Because we change position relative to the sun, that results in one end or the other being tilted towards or away from the sun, or both ends being perpendicular. So there are two factors. It is the tilt and the revolution. Now, if we take a look at this diagram, you can see that the seasons are labeled for the northern hemisphere. Always look to see, are we talking about the northern hemisphere? So you'll see down here, the north end is tilted away. So this is winter. After winter, it is spring. After spring, it's summer. You see how the north end is now tilted towards the sun. And after summer, it is fall, back to winter. Now, I do want to point out something on these diagrams. Look at these two in the middle. It would be very difficult on this diagram to determine if it is tilted towards the sun or not. Always find summer and winter on your diagrams. Look to the left and the right because those are the ones that you can actually see that tilt. You can find that axis and see that it's tilted towards or away.